In this media, we are going to discuss about engine room crane. As you all know, it's a very important and critical machinery. Even everyone is not allowed to operate engine room crane on ship. It is so important that because if it fails, if it is not in operation, then you will not be able to do maintenance on main engine. Okay, so we are going to see basically these are the basic descriptions. So a ship is like a floating structure. Now if it's a floating structure, it is being governed and run by different components. We have generators, we have engines, we have boilers, we have purifiers, we have everything. So crane capacity is designed as per your, what we call is your main engine individual component. So the crane is designed so that it can lift all the individual component of the main engine. So if it is able to lift individual component of main engine, so then it will be able to even lift other parts as well if we need anything. So it is designed as per main engine. Sometimes two cranes are fitted. Normally the range is between 0.5 to 15 tons. Okay, and electrical officer and first engineer, they are in charge and they are supposed to do regular maintenance on engine room crane. Okay, and engine room crane consists of a motor coupled with wire drum so that the motor can lift or lower the crane hoist by winding or unwinding the wire over the drum. The whole system is then fitted in a trolley. Okay, trolley, and the trolley moves. So people who working on ships, they are familiar with this aspect of engine room crane. Now see, that is the picture and that is the motor and the trolley that we are speaking about. Now two pathways are built with a rack and pinion arrangement both in transverse and longitudinal direction of the engine room and over the main engine, where the trolley is placed so that the whole unit can move fore and aft, port and starboard. So these are the four directions: forward and aft, port and starboard. A remote is provided so that the crane can be operated from any position, thus allowing the user to keep a safe distance from the lifted load. It is the duty of the responsible engineer on board to operate the crane and have a regular check on the safety and working of the crane. Second engineer is responsible for operation, maintenance and safety checks of the engine room crane. Second engineer, or in some companies we tell first assistant engineer, so those are the same, those are they are the person who is responsible. Now safety features, though I have covered in a separate video the safety features, the most important safety feature of the crane is the electromagnetic fail-safe brake, which allows the crane to fail with the load even when there is a failure of power. Okay, so even if when the power fails, the load will not fall. Okay, so it's a fail safe. That should happen na? If suddenly power goes, you have lifted the load and suddenly power fails, then what will happen? Your load will fall and it will bang on the ground. So it should not happen. So that is what it means, safe, fail safe means. Normally centrifugal brakes are used, which are fitted inside the rotating drums. The brake pads are always in applied state and pushed by magnetic springs when not in operation or when there is a power failure. As the crane is operated or the power is supplied, the spring gets pulled inward or compressed due to the electromagnetic effect of the current. This allows the crane to be operated normally. So that is the whole how this fail safe, these springs and the brakes are acting when your power fails. Emergency stop is provided in the remote so that the operator can stop the crane at any time. The motor is fitted with the distance limit switch in both transverse and longitudinal direction so that the travel of the trolley and hence crane should not overshoot the rack's end. Mechanical stoppers are provided for both directions in case the electrical distance limit trips fails. The up and down travel of the hook is also attaches with the automatic stoppers to avoid overloading of the motor. The motor is fitted with the thermal protection trip. When the motor windings gets overheated, trip will activate, saving the motor winding from burning. Load limit switch is also fitted, which will trip the motor if the load to be lifted is above the crane capacity. So that is the reason why that is safe working load on every hook, every crane there it is written what is the SWL, that is safe walking limit. Now it's the responsibility of senior officers to operate the crane and to make sure all the personnel involved in any lifting operation are at the safe distance during the operation of the crane. Additional tools like eye bolts, shackles, wire slings, belts, etc. used for lifting must be checked before use. It should be noted that no one walks or stands below the crane when it is in the loaded condition. So that is a very important thing. You should not be able to walking, you must be able to at the safe distance, because these are mechanical electrical thing, they can fail at any time. We cannot rely 100% on them. We have to use our common sense, because crane failure and crane accidents are always fatal to human health, and as well as they are for machineries as well. Okay, thank you so much. Thank you for your valuable time. All the very best for your future endeavors.